So how can we improve the solution? Is there a way to implement domain events without introducing the drawbacks we discussed previously? Fortunately, yes. The idea is that instead of raising the event right away, we should distinguish two separate notions, creating an event and dispatching it. Entities should be responsible for the creation of domain events only, whereas the dispatching functionality should be attributed to infrastructure. This way, we will be able to maintain the concept of unit of work in our codebase. Let's implement that in practice. This is where the aggregate root base class will help us. It will store all domain events created by an aggregate so that they can be dispatched later on. Here's how it looks like. We define a list of domain events and two methods working with them. Add a new domain event and remove all events. Note that the add domain event method is protected. That's because the responsibility to create an event should belong to the entity itself. We shouldn't commission it to external code. So now, as we've defined the collection, we can replace this code here with adding a new event. Our domain entity is no longer responsible for raising it. All it does is saves it to the internal list. Alright, we have entities with domain events attached to them. How can we process those events? And not only just process, but do that in a way that allows us to preserve the unit of work semantics. In other words, take an action only when the business transaction is committed. To do that, we can rely on our ORM. And Hibernate provides several extension points that allow us to inject our code into its internal pipeline, so that it would be executed only when some persistent event occurs. In our case, we need to process domain events only when the aggregate was successfully persisted into the database. To do that, we need a new class, Event Listener. This class will implement four interfaces, like this. Let me put them on a single line so that you can see them. All four methods we define in the class call a private dispatch events method that performs the actual dispatching. Let's take a minute to discuss how this technique works. These three methods, post-update, post-delete, and post-insert, are used by Hibernate after an entity is updated, deleted, or inserted. There also are interfaces for listening for their counterparts, pre-update, pre-delete, and pre-insert, but they don't fit our needs because until the operation is finished completely, there still is a possibility for it to fail, for example because of a database constraint violation. So the use of post-persistent events allows us to dispatch domain events only after the persistence operation is completed and thus preserve the unit of work semantics. Note the post-update collection method here. It is triggered after a collection update. We don't need it in our application, but I include it here so that you can use this code as is in your own project. This method is required in some sophisticated update scenarios. For example, if a snack machine in our domain model could change the number of slots, and we for some reason wanted to raise a domain event every time it happens, we wouldn't be able to just use the post-update method. The snack machine entity itself in this case wouldn't change, and so in Hibernate wouldn't trigger the post-update event for it. What it would do instead is it would fire a post-update collection event. That's why we are listening to it here. That way, we are sure the domain events get processed regardless of whether or not the entity's fields are changed. The dispatch events method, as you can see, just goes through the domain events collection and dispatches them one by one. After that, it erases it. To make Hibernate aware of the domain event listener class, we need to specify it in the configuration, like this. And let me put each array on a separate line. Alright, as you can see, this dispatch method here doesn't yet exist. We need to modify the domain events class first. Here's the current implementation. I'll copy it to a separate file so that you can review it and compare with the new implementation later on. The new version doesn't need the dynamic handlers anymore, so I remove the dictionary and the register method. We also won't need it in the raise static method. And I rename the raise method into dispatch because it better represents its functionality. We don't raise an event with the domain events class. We only dispatch the events that were created by domain entities. When we dispatch events in the event listener class, we no longer know their concrete types. They all are of the iDomain event type for us now. So we don't need the type parameter in the dispatch method anymore. And we can rename the static handlers to just handlers, because it's the only type of handlers we have anyway. Let me also rename handler to handler type. Okay, to actually check that the handler is capable for handling the event we're dispatching, we need to employ reflection. And to handle the event, we can use dynamics. We also could use reflection here, but the code would look quite cumbersome. Dynamics work much better in this particular case. Alright, now as we've changed the way we work with domain events, we can change the unit test. No need to declare the event upfront and use the register method to capture it. What we can do instead is we can grasp the balance changed event from the ATM entity and check that it's not null and that its delta property is indeed the right one. All tests are passing, very good. And you can see the test working with the domain event has become much more succinct. That's because we removed the smells we introduced with the previous implementation. To raise the readability of the test even more, we can create an extension method for the ATM entity, which would allow us to check the event using a one-liner. So instead of these 3 lines here, we can write should contain balance changed event and specify the actual change. Perfect. Let's see how it works in practice. I'm taking a $1 from the ATM. You can see the number of $1 bills in the database has changed, and so has the balance in the head office instance. Very good, we have implemented the new approach to working with domain events. Let's recap what we've done in the previous demo. First of all, we've split the 2 responsibilities that were bound together before that, creating a domain event and dispatching it. Our entities are now responsible for the creation of events only. The actual dispatching is given away to the infrastructure. This implementation allows us to preserve the isolation for our domain model and also adhere to the notion of unit of work. In terms of processing the events, we rely on the internal in Hibernate mechanics, which gives us a great opportunity to extend its behavior with our own code. We listen to the events in Hibernate raises when it finishes persistent domain classes. We dispatch the domain events only after the persistence is completed. This allows us to maintain consistency between the changes made to our aggregates and the domain events we raise. Also note that we define the collection of domain events in the aggregate root base class. That's no coincidence. Just as aggregate roots are responsible for maintaining aggregate invariants and consistency boundaries, they are also responsible for all domain events occurred in the aggregate. As you can see now, domain events is a powerful tool which facilitates communication between bounded contexts. I mentioned earlier that you can use the concept of domain events regardless of what type of physical delivery is chosen for them. Here I want to show you an example of how you can implement communication between bounded contexts which reside in separate processes, in other words, between microservices. This is how we could send domain events to other microservices. You can see this is the same event handler as before, but this time, instead of executing the actual code for handling the event, it sends an ASB message via message bus. This message is then received and processed by whatever microservice is listening to this particular kind of events coming from the message bus. Also note that this version of the handler resides in the ATM bounded context. That's because the responsibility to send the event to the message bus lies on the bounded context producing it.